Hello, I hope you're having a wonderful day and welcome to the Azure Firewall Solution demo. My name is Mohit Kumar and I'm a Senior Program Manager on the Azure Network Security, Customer Experience and Engineering team at Microsoft. In this demonstration, I will walk you through the security detection and automated response capabilities for Azure Firewall that are included in the Azure Firewall solution for Azure Sentinel. If you're watching this video and you're not familiar with the Azure Firewall solution, or if you haven't read the blog post on Azure Firewall solution on our tech community page, there's a link to it in the description of this video. Please check it out for more details. Here are the topics we'll be covering in this demonstration. First, we will understand how the demo environment is set up. Then we'll look at how Azure Firewall and Azure Sentinel in the demo environment are configured. And finally, we'll run a port scan from one of the virtual machines in the environment to another VM through Azure Firewall. We'll also see how the automated response works with the Azure Firewall playbook. So let's first understand how our demo environment is laid out. As you can see on the screen, we have 3 VNets in the environment, of which 2 are spokes and 1 is a hub. Starting from the left, we have our client VNet, which has an IP range of 10.20.20/24. The Kali Linux machine in the client VNet has an IP address of 10.20.25, and this is the machine on which we'll be initiating a port scan. And our target will be the server 2019 VM in the server VNet on the far right. Moving to the middle, we have a hub VNet where we have an Azure Firewall which filters traffic between the client and the server spokes. And then moving to the right, we have our server VNet, which is also a spoke and has an IP range of 10.30.30/24. We have a single machine there, which is a server 2019 machine. The IP address of the machine is 10.30.34, and this machine will be the target of the port scan we will initiate from the Kali Linux machine. An important thing to note here is that the client and the server VNets cannot talk to each other directly. They do not have any direct connectivity between them. And the way they get connectivity to each other is through VNet peering to the hub VNet, which is where Azure Firewall filters traffic between the 2 spokes. Now that we know how this environment is set up, let's look at how our Azure Firewall is configured. In this environment, we have an Azure Firewall Premium running, which is managed with the firewall policy. For this demonstration, we have 2 network rules in place, Rule 205 and Rule 203. Rule 205 is an allow rule which allows all traffic between the IP addresses of the client and server VNets. Traffic is allowed for any protocol and all ports. Rule 203, on the other hand, is a deny rule which is expected to deny all traffic which is originating from IP addresses which are in the scanner IP's IP group. An IP group is a collection of IP addresses in Azure which can be used in Azure Firewall rules. If we were to look at what IP addresses are included in the scanner IP's IP group at this time, we go to the IP group and take a look, and we see that there are no IP addresses in this IP group, which means that Rule 203 is not denying traffic from any IPs at this time. What we're expecting to see is that after we run a port scan from the Kali machine to the server 2019 machine, it is detected by Azure Sentinel based on the port scan detection rule. And the playbook automation, which is attached to the port scan detection rule, will add the IP address of the Kali machine to the scanner IP's IP group, which in turn will block any further port scans from the Kali machine. Okay, now let's take a look at how Azure Sentinel is configured for this demo. We have already deployed the Azure Firewall solution to the Sentinel workspace in preparation for this demo. As a result of that, we have 5 new detection rules which are provided by the Azure Firewall solution, in addition to 5 new hunting queries as well. All the detection rules which came as part of the Azure Firewall solution are disabled, as you see on the screen, except for the port scan rule, which is enabled. And this is the rule we will be using in the demo. This port scan rule looks for specific patterns in the Azure Firewall logs to identify port scanning activity, and if there's a match, it will create an incident in Azure Sentinel which will be logged in the incidents blade. And as you can see, right now we don't have any incidents. Now, if you're following the blog post for the Azure Firewall solution, which is linked in the description of this video, You know that the port scan rule is set up to analyze log data from 24 hours ago. That's the out of box behavior. If you want to check if the port scan is being detected in near real time, you will need to comment out this line in the KQL query. I also want to mention that all the detection and hunting queries included in the firewall solution, like any other detection or hunting query in Azure Sentinel, are based on KQL, and you can modify them to suit your needs. In addition to the detection rule being enabled, we also have an automation rule which is attached to the port scan detection rule. And how this automation rule works is that when an incident is created in Azure Sentinel, it checks the name of the analytic rule in the incident details. And in this case, if the analytic rule name were to match port scan or contain port scan, it will run a playbook that we have already deployed in this environment. The playbook attached to this automation rule is called block IP and add IP to an IP group. When this playbook is triggered based on the Azure Sentinel incident, it will send a notification in a Microsoft Teams channel defined in its configuration, at which time the analyst triaging the incident can either ignore or act on it by adding the IP address of the port scanner to an IP group. Both actions can be taken from Microsoft Teams notification, which is also called an adaptive notification. In our case, we will be adding the IP address of the port scanner to the scanner IP's IP group to block traffic from it based on the firewall rule definition that we saw earlier. So let's recap. So far, we've seen how the demo environment is set up and how Azure Firewall and Azure Sentinel are configured in this demo environment. Now we'll go ahead and run the port scan. Before we run the port scan, let's verify that the VMs have connectivity. So here's the Kali VM in the environment, and as you can see, the IP of this machine is 10.20.20.5, and the IP address of the Server 2019 machine that we're going to target for a port scan has an IP address of 10.30.30.4. So let's see if the ping connectivity is working, and looks like it is. So we'll stop this, and we will also verify ping connectivity from our Windows Server 2019 machine to the Kali machine. So this is the Windows Server 2019 machine. It has an IP address of 10.30.30.4, and we'll run ping to our Kali machine from this machine, and we see ping connectivity is working. Okay, so we're ready to run the port scan. So for this, I'm going to use nmap, and I'll start the port scan now. Okay, so the port scan is running, and it is discovering open ports on the Windows Server 2019 machine. Windows Server 2019 machine in our environment is also a domain controller, so we expect to see all these ports open. We'll give it a few minutes to complete the port scan. The port scan is still going. So our port scan is now complete, and we see that it has found quite a few open ports on the Windows Server 2019 machine. While the port scan was running, the traffic from the client spoke to the server spoke was being processed and allowed through the network rule in Azure Firewall. At the same time, Azure Firewall was writing the details of network traffic to its logs in the designated log analytics workspace. The log analytics workspace is integrated with Azure Sentinel, which means that Azure Sentinel is able to ingest all of the Azure Firewall log data and then run the specific enabled analytic or detection rule on it. In our case, that's the port scan. What should happen now is that based on the port scan rule we have enabled, Azure Sentinel detects the traffic we generated from the Kali machine as port scanning activity and creates an incident for it in the incidents blade. So let's look at the incident blade. This will take a couple of minutes, and we'll just wait and refresh. Okay, so here it is. We now see an incident for the port scan, which has been generated by the port scan detection rule in Azure Sentinel. And if we look at the incident details, we see the name of the detection rule or the analytic rule which created this incident. And we also see two IP entities here. IP 10.20.25 is for the calling machine in the environment from where we initiated the port scan. And then 10.30.34 is the IP address of the Windows Server 2019 machine, which was the target of our port scan. Because there's an automation rule attached to the port scan detection rule and the incident has been created, this should have triggered the playbook attached to the automation rule. If you'd like step-by-step details about the configuration of the detection and the automation rule we're showing here, please check out the blog post linked in the description of this video. Now, if we were to head over to our Microsoft Teams channel we had configured for the playbook, we should see an adaptive notification related to this port scan incident. And it should give us details of the incident and also provide us choices of action we can take for the incident notification. So let me bring up my Microsoft Teams channel, and here is the incident notification. It provides us details about what was detected and what was the source IP of the detection, in this case the IP address of the Kali machine. And then we have options to either close the incident. You have the multiple choices here. You can choose to close an incident as a benign positive in case this was an expected activity. A port scan was run by a penetration team or a red team in your organization. You can close the incident as a false positive or true positive as well. You have the ability to change the severity of the incident itself. And then in terms of response actions, you can ignore the incident altogether by clicking the ignore button, or you can take the playbook specific action by clicking this button. And in our case, we are going to add the IP address of the port scanner to the scanner IP's IP group. So let's click this button and it'll open up another option which will give us a drop-down menu. And this drop-down menu will show us all the IP groups we have in our environment. In our case, we're going to add the IP of the Kali machine to scanner IP's IP group. So I'm going to go ahead and select that and then click OK. Now that this is done, we will go back to Azure and we will check the scanner IP's IP group. And as you can see, there was no IP address added to it till now. But now that we have run the automation from the adaptive notification in Teams, let's refresh and we should see the IP address of Kali machine here. And there it is. The IP address of Kali machine is now added to scanner IP's IP group. And if we go back to firewall policy, scanner IP groups, IP group is configured in a deny rule. And this will deny all traffic which is originating from IP addresses which are included in the scanner IP's IP group. And what this should do is it should block any traffic from the Kali machine going forward. To test this, we will try to run a port scan again from the Kali machine to see if it's successful or not. Now, before we run the port scan again, I quickly want to show you what happened to the incident in Azure Sentinel. As you can see, this incident is now closed and there are comments updated in the incident which was done by the playbook. So you can see Azure Firewall performed the following action. And if you click on this hyperlink, you will see all the details. And the action that was taken was that the IP address 10.20.25 was added to an IP group. Okay, so we'll go ahead and run our port scan again. So here we go. And this time we should see the port scan fail, and that's exactly what we're seeing. To summarize, Azure Firewall solution for Azure Sentinel includes detections, hunting queries, and response automation with playbooks and Logic App Connector, which you can use to detect threats and respond to them automatically in Azure Firewall. The way this works is Azure Firewall processes the traffic and logs all traffic data to its log analytics workspace, which is ingested by Azure Sentinel. Azure Sentinel detection rules look for pattern matches and create an incident. The automation rule in Azure Sentinel triggers the attached playbook when an incident is created and sends a notification to a Microsoft Teams channel. The analyst can decide what actions to take, whether to ignore or act on an alert from Microsoft Teams. And when the playbook action is taken, the playbook makes changes to the firewall configuration using the Azure Firewall connector. I hope you enjoyed this demo, and please check out the detailed blog on Azure Firewall solution. There's a link to it in the description of this video. Have a great rest of your day. Thank you.